In this lesson, we'll take a look at how to write a quadratic equation given a pair of solutions. In order to do that, we want to first refresh our memory on how we solve a quadratic equation by factoring. If you take a look at the left side of the screen, we want to solve this quadratic equation, and we do so by writing the two factors. In this case, our two factors are x plus 8 and x minus 2. We know those to be our factors because 8 times negative 2 gives me negative 16, and 8 plus negative 2 gives me 6. We then recall that we set each of those factors equal to 0 and solve. So we get x is equal to negative 8, or we get x is equal to 2. If we translate this and take a look at what we're now asked to do, we're asked to write an equation that has these exact two solutions. So what we want to do is we want to proceed by taking each of these steps that we just solved on the left side in the reverse. So if we write this out, our two solutions must be x is equal to negative 8 or x is equal to 2. In order for x to equal negative 8, then x plus 8 equals 0 must have been the equation that we would solve in order to get negative 8. And we know x minus 2 equals 0 would give us a solution of 2. Well, if each of these are factors and we multiply them, we know that we get an equation of x plus 8 times x minus 2, and that would have to equal 0. The only thing that we have left then to do is to just FOIL. So I have x squared minus 2x plus 8x, or plus 6x, and then minus 16 is equal to 0. This would be the quadratic equation that has a pair of solutions of negative 8 and 2. So notice we just reversed the steps from the left side to the right side. So let's apply those steps now, given a more difficult example. This time we want to write our quadratic equation given two solutions. They're imaginary. So if I write this out, I know my two solutions must be x is equal to 3i root 2 or x is equal to negative 3i root 2. This means that I have two factors. I have a factor of x minus 3i root 2, because that would give me 3i root 2 as a solution, or x plus 3i root 2, because that would give me negative 3i root 2 as a solution, and these two factors have to equal 0. So I'm left now to FOIL, and I want to just be careful when I'm foiling this. If I take my first two terms, x times x, I get x squared. My outside terms are going to give me 3i root 2 times x. Then my inside terms are going to give me minus 3i root 2 times x. And then my last terms are going to give me minus 3i root 2 times 3i root 2. And all this equals 0. So in my middle here, I notice that these are opposites, and therefore they go to 0. So I'm really left with x squared minus, and I want to actually multiply this out. So let's simplify that a little bit. 3 times 3 is going to give me 9. I times I is going to give me I squared. And then square root of 2 times square root of 2, just to be detailed, I'm going to put square root of 4. And to simplify this further, I know that I squared is going to give me negative 1. And I know the square root of 4 is going to give me 2. So if I multiply this out, the equation that I get is x squared plus 18 equals 0. This is my answer, or the quadratic equation that would yield the two solutions. And if I want to check my work, I want to check my work, I could solve this. So I could say, well, x squared plus 18, where does that equal 0? And it equals 0 if I minus 18 from both sides. I have x squared equals negative 18. And if I take the square root of that, including a plus or minus, I end up with x equals plus or minus 3i root 2, which was in fact exactly what I was given. So you can always solve and then check your final answer.